Hey class, we're still in Module 1. In this lesson, we're talking about types of bias in clinical research. This is probably not news to you. The truth is, we all have biases. We all have underlying foundational beliefs, experiences that we bring in to interpret the world around us. And there's a lot of people out there with a lot of different backgrounds, so we all don't see it the same. This is bias. I've thrown in here a few cartoons to help us grasp this idea. Now, yes, we all have biases that we bring in to our critical thinking, but here we're talking specifically about bias in research. And here's a pretty fun and simple question, one you can ask your kids. What do you think they would say to this? Okay, we all have our cultural backgrounds and beliefs that probably help us answer this, and yet we're going to get varying and different answers among so many of us. So how do we take a question that brings up so much subjectivity and make it objective? This is challenging in the world of research. This is a fun question to consider. I just want you thinking critically and thinking how much your own bias goes into these questions as we approach this topic of bias and the challenge that it is within scientific research community. So we have three objectives for this lesson. One, to identify the important reasons to consider bias in research. Two, to define bias. And three, to recognize types of bias. We've talked about the humanness of bias. We definitely see it all around us. Now, what about with research? Why is it important to consider bias in research? Well, bias present in research can really undermine the validity or strength of the findings. Whether it's the researcher that has added bias into the study or another factor, which we'll talk about identifying many different types of bias that takes that truth, the accuracy of the truth, and puts it on the wrong path. And more it's on that path that veers away from what is actually real, what actually comports with reality. So what can we do? We need to understand bias. Well, we need to know and be very self-aware of biases that can creep into our research. Authors, researchers need to, one, be aware, and also within their presented research mention steps to avoid those potential biases. I worked in the world of research for several years and did cancer-specific research. When you're doing cancer-specific research, I should say when I'm doing cancer research, I definitely had eyes looking at my research of wanting a positive result instead of wanting the data to just lead me wherever it goes, positive, negative, whichever direction. So I believe as I really looked at that research and spent time with it, I probably saw things of, oh yeah, that's a positive result. Oh, it sure looks like that's causing those cancer cells to aggregate. And I think a lot of that hindsight, now that I know more, was more subjective interpretation of the results. Fortunately, in my lab, we had lots of different eyes looking at the same things. So specifically in research, our definition here is deviation from the truth in data collection, analysis, interpretation, or publication. This may be conscious or unconscious. Kind of as I explained, I can look back and see it at the time completely unconscious of my desire and hope for positive outcomes in cancer research. Just as I think about that and I verbalize it so much, I think of the issue there is me talking about positive versus negative outcomes. Ultimately, if I would have just considered outcomes. no matter what. If it's a null hypothesis and scratch that didn't work, that's still progress. But that's not how I viewed it. I wanted to be a part of this amazing thing in cancer research. So a quick assessment on our objective of defining bias. True or false? Bias in research is always conscious by someone involved. That's definitely a false statement. It's not always a conscious decision and often unconscious, and we'll talk about that as we continue on the types of bias. In this lesson, we'll talk about 5 types of bias. There are more than 5, and each bias can have a different name. The biases we'll talk about today are selection bias, attrition bias, measurement bias, publication bias, and surveillance bias. Some of these can be quite intuitive considering their names. Okay, can you identify the type of bias here? The scenario: you design a longitudinal study to investigate whether an educational program can help college students manage their alcohol use. In your study, many more participants drop out of the treatment group than the control group. You're left with 30 participants in the treatment group and 65 in the control group. Most of the participants who drop out from your study consume much more alcohol than those who stay. Does this skew your results? Yes, absolutely. Which type of bias do you think this might be? Here's another scenario. You are part of a research team investigating whether lower socioeconomic status exposure is related with higher risk of cervical cancer outcome. You conduct a case control study to find out. Laid out below are the subjects. Women with cervical cancer from all over the state come to your hospital for treatment. And that is where those patients are recruited for your study. They're given the study questionnaire. Okay, and then your control subjects, women without cervical cancer, are recruited by going door to door in the neighborhoods surrounding the hospital between the hours of 9 a.m. and 5 p.m. They are given the same study questionnaire. Are there any problems that pop into your head as you look at the 2 subject groups? Which bias do you believe this might be? Let's look into all of these. Let's start with selection bias. Selection bias occurs when the selection of subjects into a study leads to a result that is systematically different to the target population. So essentially, simply, the way subjects are chosen or assigned can skew the results. One simple example would be to understand the burnout effects of healthcare workers during the COVID pandemic. And then our sample, because I'm a respiratory therapist and just wanted to talk to my friends about it, ends up being mostly or exclusively respiratory therapists. Is this going to skew my results when my research aim was among all healthcare workers? My guess is that you're going to have a very, very high level of burnout in the smaller population that doesn't represent the fullness of the variable that you are trying to look at. Selection bias is usually associated with research where selection of participants is not randomized. This is most common with observational studies, such as cohort, case control, and cross-sectional studies. But it also can occur in interventional studies due to poor randomization. So that will be something that you are looking for as you are critically evaluating research. We'll talk more about that in the future. So here is our example of selection bias. This is an example that we had at the beginning, considering women with cervical cancer. Your scenario is that you're part of the research team investigating whether lower socioeconomic status is related with higher risk of cervical cancer. Your experimental group is women with cervical cancer from all over the state come to your hospital for treatment. And that is where those patients are recruited for your study. They're given a questionnaire. Your control groups are found by going door to door in the surrounding neighborhood from 9 to 5. So the glaring bias here is that those with cervical cancer come from all over the state, while the women without are nearby from 9 to 5. So the two groups were selected in completely different ways. That really adds variables to your research that are going to skew your results, or confounding variables. So the demographics for the cervical cancer group are going to be much more diverse. They come from all over the state. So things such as socioeconomic status, possibly age, cultural and exposure backgrounds, race, accessibility to medical care and healthy food, where the demographic of your control group is going to naturally be a lot more uniform because of the way you selected them. And also considering that our independent variable is the socioeconomic status, here we have knocked on the doors from 9 to 5 around the hospital, and we have to consider who's home 9 to 5. I am with my daughter, but also probably a larger population of those who are unemployed. So here's definitely a potential confounding variable that may skew the results. So what are ways to avoid selection bias? In observational studies, this is studies without a specific intervention, just observing, is trying to make the control group as comparable to the treatment group as possible, such as our previous example. If they're taken from all over the state in the experimental group, they should also be taken from all over the state in the control group. In experimental studies, where there is an intervention, we need to use proper randomization techniques. Now, as you are critically evaluating your research articles, you're going to look and evaluate what randomization techniques were used. Were they proper and appropriate, or do they add bias to the research? And another way to avoid selection bias is applying appropriate and stringent inclusion and exclusion criteria. Again, we will evaluate the research we're looking at, and I'm giving you these tools to be able to identify selection bias so that when you are evaluating your research article, you can pick out these parts, the inclusion and exclusion criteria, the proper randomization techniques. The next bias we are on the lookout for in our research is attrition bias. Attrition bias is pretty simple. Attrition means loss. So when it comes to research, attrition is the loss of subjects between study enrollment and the final data collection. Some attrition is normal, and it creates bias when it leads to major differences or imbalances in the study groups. As we look at our research articles, we will be looking at the enrollment from the beginning to the final collection and looking at those numbers and how much attrition there is. Where again, some attrition is normal. In longitudinal studies, ones that go over a long range of time, maybe even years, we definitely see attrition. But bias is when that attrition does lead to imbalance in the groups. And the sample is now biased because some groups from the population are underrepresented. This was the second scenario. Actually, this was the first scenario that I had given you about the longitudinal study to investigate whether an educational program can help college students manage their alcohol use. And here we had a lot of dropouts in the treatment group, where there's only 30 left in the treatment group and 65 from the control group. Those who left the treatment group consumed much more alcohol than those who stayed. So, does this skew your results? Absolutely. Your final sample is skewed towards the college students who consume lower to moderate amount. They're the ones that stayed in the study. Therefore, your findings aren't applicable to all college students because your sample underrepresents those who drink larger amounts of alcohol. So, how do we prevent this attrition bias? Ultimately, researchers want to be able to follow up with 100% of the participants. So, how do we get people to stay in the study? One way is to provide incentives or compensation for participation in the follow-ups. We also need to make the follow-up process pain-free and simple as possible for the subjects. And then finally, we can oversample and recruit more participants than are actually needed for the research to account for that attrition. So later in the class, we will be discussing statistical power and sample sizes. So it's pretty common for researchers to oversample, to have more than enough participants, in the end to be sure that your study has enough participants to adequately power it. Again, we will talk about that statistical power with sampling later in the course. Our next bias is measurement bias. Measurement bias is the systematic differences in how outcomes are measured between study groups, or inaccurate or inconsistent measurement of study outcomes. So this is introducing bias in the way that we measure the outcomes. There are many reasons why this may occur. It could be the measuring tools, that they're inaccurate or inconsistent, especially those ones that are highly subjective, questionnaires, scoring tools, and it is not providing accurate or truthful numbers. But maybe one of the things we're measuring is ABGs, and different facilities are doing the research and utilizing different equipment for their ABGs. Maybe the equipment is calibrated differently or doesn't meet ATS standards. So calibrations of equipment, lab equipment, pulmonary function test equipment is incredibly important when it comes to research. Human error is always a possibility. We're all humans and accidents definitely can happen. And then the final reason I have here is when data collection is not blinded. Blinding means that those who are collecting the data do not know which study group is which. So if it's not blinded, then as they are collecting data, they know who belongs to which study group. So if the collection is not blinded and that person is aware, that just adds that variability of opportunity for bias. So how do we reduce measurement bias? Calibration. Calibration is hugely important with those objective measuring tools. When it comes to the more subjective measurements, such as questionnaires and scoring tools, we could use only validated questionnaires or go through the process ahead of time of validating that questionnaire. If possible, it's good to have all sites utilize the same equipment. Data collection should be standardized. There should be a protocol on how to collect that data. And as we talked about, ideally that data collection is blinded. So those collecting the data do not know what subject group they're collecting. Next is publication bias. Publication bias refers to the failure to publish the results of a study on the basis of the direction or strength of the study. So essentially, I'm not going to publish this because I don't like the results, or the results aren't what I expected, or the results may harm the future of my company. Or I told you about my own bias going into research, and while I was in research, I viewed my research through, I needed positive results. Now, fortunately, I was just a young graduate student that didn't have a lot of authority there, and I had a great boss ahead of me and a whole team to work around me. But you can see how, hey, if this looks negative, it looks like it didn't work, do I just ignore it? Or do I put it out there so that the public can see it and not repeat, whether it's repeat my mistakes, but then they can head the right direction instead of the wrong direction. My negative results are just as useful and effective for the scientific community. So what's wrong with this? I think that's pretty obvious. But this really has long lasting effects on the scientific community and what's shared with the public. Researchers may waste effort and resources conducting studies that have actually already been done, but they weren't published because they did not prove effective, or because whatever the reasoning that that researcher decided, oh, I'm not going to publish these results. Yet they could have really been valuable for the scientific community to not waste the effort, time, resources, money, blah, blah, blah. It really limits not only the scientific community's ability to thoroughly understand that topic, but it limits all of our knowledge, and to take that research in the right direction versus maybe it's heading in the wrong direction. And then published studies can no longer be a representative sample of all the available knowledge, distorting results of an entire meta-analysis. Surveillance bias occurs when simply just observing seems to change the outcome. Are we seeing more of something because its prevalence is increasing? Or is it because now we're actually looking for it? When we're talking psychological studies, people's behaviors changing when they know they're being watched. I remember in college, I had a college roommate who was doing a psychology research project, and I knew she was doing it, and I knew she was watching me and friends, and I had no idea what she was watching for, but I know because of my own awareness to it that it affected me and I changed because of that. Another thing, we have such advanced technologies today when it comes to cancer research and cancer diagnostics. Are we seeing more cancer today just because we're looking for it? Are we seeing more today because it is more prevalent than it used to be? All right, our quick assessment after objective 3 of recognizing types of biases. What kind of bias would you be considering if you saw these specific results? Happy learning. Please connect with me if you have any questions or concerns again this week. And don't forget to read the article below, Identifying and Avoiding Bias in Research.